first two are really easy because we had coefficients of 1. These went right into here, so you have x minus 4, x minus 3. X minus 5, x plus 2. So for number 3, we're doing the same thing again. So this is our product, which is a negative 16, but this time our sum is positive. So I know to get y squared, I did y times y. To get and because my sum is negative, or product, I put 1 of each. And so I'm looking at 8 and 2, right? Because 8 and 2 will subtract, but I need that to be positive 8 and 2. Positive 8, negative 2. Okay, so those first 3 were simple, easy, and not a lot of work to be shown. So when you get to number 4, this is what I was talking about. Make sure you pull the GCF out first. Because a lot of you looked at that and went, that's not difference of 2 squares. Oh, but wait, if you pull this out, you get x squared minus 25. And that is a dots problem. There's 2 terms, they're both squares, and you had to take that further. If you left it, then you didn't factor it completely, and then this would not be a 4. So this would be factored into an x plus 5 times an x minus 5. So I had a lot of people try to make this like 2x plus 25, 2x minus 25. And there's a difference between taking half and taking the square root, right? Half of 50 is 25, but the square root of it isn't, okay? So then this next one, you could have just went and did 3 times 75 and had some big giant number. But if you pulled a 3 out, look at your paper. Did you pull a 3 out? And that would have left you with x squared plus 10x plus 25. And then that's a 1, which means that I do it just like I did numbers 1, 2, and 3. I'm thinking of 2 numbers that give me a product of 25 but a sum of 10. That's easy. It's 5 and 5, right? Okay? And because the sum is positive, both my 5s need to be positive. But what about that 3? What do I do with that 3? It comes along as part of my answer because it's a factor. So I have an x plus 5 times another x plus 5. And for those of you fancy pants, you wrote it like this, didn't you? Okay? Yep. Fancy pants. Yes, your pants are fancy. Number 6. There is no GCF, and that is not a 1. I have no option but to do the long way. Okay? So I am making my x. I'm doing my a times my c, which is negative 8, and my b is 7. That's easy. 2 numbers that when I multiply to get negative 8, but add to get positive 7 has got to be what? A positive 8 and a negative 1, right? Because that needs to be positive. Okay, now be careful because you promised me that you would not take these and make them into the parentheses like I did here because of that 4. So what I'm doing is I'm taking 4x squared. I broke that 7x down into a positive 8x and a negative 1x and then minus 2. And now here we go. This is factoring by grouping that you need to be pretty comfortable with. And now when I look back on it, I should have given you a test just on factoring by grouping and made sure you were good with that because I feel like that's what's holding some of you up. So now pull this GCF out, which is a 4x. What are you left with? X plus 2. Bring that minus down. Hey, there is no GCF. So then you have to at least pull out a 1. Pulling out a negative changes this. And now that those match, I have my common factor of x minus 2 and my leftover of 4x minus 1. Okay? If there was a squared there, I would make this 2x plus 1, 2x minus 1. But it's not squared. Okay? All right. This one is already broken down for you. It's already in 4 terms. If the goal is to get it to be 4 terms, and it's already 4 terms, they did the x for you. Do you understand that? So now I'm pulling out an x to the second, which is leaving me with an x plus 4. Guys, ready? I'm pulling out a negative 25. You are checking your work right now. This is the reason we're doing this. And that's leaving me with an x plus 4, which is great. So I have an x plus 4, and then look out, I have an x squared minus 25. If you left it like that, it's not completely factored because that is a dots problem. Both of those are perfect squares, so you have your x plus 4 times your x plus 5, x minus 5. Got it? It's the same problem as number 4, basically. You had an x squared minus 25 and 2 problems. I need to redo this task. Okay? All right, next problem. I'm looking. I don't see a GCF. I see a coefficient. I got to do this one the long way. I got to factor by grouping. 3 times 6 is 18, but a sum of negative 19, that's easy. It's negative 18 and negative 1. And why did I make that? To break down the negative 19. So I'm recopying my 3x squared. This is made up of a negative 18x and a negative 1x. Are you following me? Sometimes just seeing it done. So pull this out. I'm pulling out a 3x, which leaves me with x minus 6. Bring this negative down. The GCF here is 1. It changes that plus to a minus because that's a minus. And then I have an x minus 6 and my 3x minus 1. We doing okay so far? Okay, 2 more, and then we're done. Now, this one, hopefully you looked at it. You didn't see a GCF of anything because you can get a 4 out of here and a 7 out of here, but you can't get it out of all 3. So hopefully you didn't do, 49 times 4 and have to do this and have to do that. Did you recognize that these were both perfect squares? Okay, so this is the shortcut I'm trying to get you to think about. So if both of these are perfect squares, then you could just say, and the middle term did not cancel. It means it's not going to be 1 plus 1 minus. It's going to be the same. And whatever the sign of the middle term is what it's going to be. So if this is a negative 28 as a sum, I have a 2n times a 2n, a 7 times a 7. That is your answer. If you have 2n minus 7 times 2 minus 7, great. And here's how you check it. That's negative 14n. And when I have 2 of those, I have a negative 28n. If I did 49 times 4, I got 196 and negative 28. If you did it the old-fashioned way and sat there and tried to find factors of 196, it would work. You could do it. It was just a lot longer than just doing it this way, right? Okay? So this is your final answer, written either way. Okay, last one, guys. Again, if you did 100 or 42 times 12, you were dealing with a big product. Factor a 2 out because these are all even numbers. When I pull a 2 out of here, I get 6x squared minus 5x minus 21. And then I have 21 times 6. And by the way, I think a lot of you didn't know what to do with that 2. It was kind of confusing. Ignore it. Once you pull that 2 out, it's a factor. It's part of your answer, but you don't need it. So now I have 6 times this is a negative 126. Not too bad, but 5. So as I'm taking 126, dividing it by some different, I did times. So 126 divided by 4. That doesn't work. 126 divided by 14. 14 and 9. 14 minus 9. Hey, that's 5. So you see how you just kind of use that to do? So I have 14 and 9, but I need this to be negative. So the 14 goes here. The 9 goes here. That is what 6x squared plus 9x, thanks Nina, minus 14x minus 21. And then I factor, you can put it right there. I factor by grouping, okay? And then let's finish this up and be done. So I'm pulling a 3x out, Alex. And then I have a 2x plus 2, so 3, sorry. This minus a 7 can come out of there, which should also give me 2x plus 3, which means here's my 2. One of my factors is 2x plus 3, and the other is 3x minus 7. So you are looking back at all of your, I'll leave this up here for a second for you. Looking back at all of your answers down to the very last sign and everything. The order of these parentheses doesn't matter. You know that, right? Okay? So if you got everyone perfect, put a 4 on it. Okay? And then turn it in. If you don't want, and this is how we're going to do it. If you don't even want me to put it in the grade book this time, don't even turn it in. So only turn it in. So I'm hearing lots of crumples. Okay? But here's the deal. Did that help you understand why you're crumpling it now? All right? So put a 4 on it, turn it in if you want.